Example of acidic salt is NH4Cl. So the formation of salt can be formed from NH3 and HCl. NH3 is a weak base and HCl is a strong acid. Next is the salt dissociations. NH4Cl will undergo dissociations to form NH4 plus and Cl minus. NH4 plus is a strong conjugate acid because it comes from weak base. And Cl minus is a weak conjugate base because it comes from strong acid. Next is the process of hydrolysis. So the ion that will undergo the process of hydrolysis is the strong conjugate acid NH4 plus. So the equation is NH4 plus H2O will get NH3 and H3O plus. So since H3O plus is produced in this process, the pH of the solution formed is less than 7. Therefore, NH4Cl is an acidic salt. Next is basic salt. Example of basic salt is Na2CO3. First, we write down the salt formations. So Na2CO3 is come from weak acid H2CO3 plus NaOH strong base. And then this salt will undergo dissociations to form CO3 2- plus Na plus. So in order to balance the equations, there are 2 mole of Na plus. Alright, CO3 2- here is a strong conjugate base because it comes from weak acids H2CO3. Na plus here is a weak conjugate acid because it comes from strong acid NaOH. The next process is hydrolysis, and this is where we are going to determine the type of salt. So the one that undergo hydrolysis is the strong conjugate base. So CO3 2- plus H2O, we get HCO3- plus OH-. So from this hydrolysis, hydroxide ion is produced. And that means the pH of the solution formed is more than 7. So therefore, Na2CO3 is a basic salt. Example: sodium cyanide is a salt formed when a strong base NaOH is reacted with a weak acid HCN. Write a balance equation to show the reactions between sodium hydroxide and HCN and classify the salt form. What would be the expected pH of the NaCN solutions? Explain the answer using equations. Okay, so first, we need to write down the equations of the salt formations. So NaOH plus HCN, we get NaCN plus H2O. So NaCN is a salt. The second equation, NaCN will undergo dissociations to form Na plus and Cn minus. So Na plus is a conjugate acid of strong base. That means Na plus is a weak conjugate acid because it comes from strong base. So Na plus does not hydrolyze in water. Cl minus is a conjugate base of weak acid. That means Cl minus is a strong conjugate base. So this strong conjugate base will hydrolyze in water. So the equations of the hydrolysis of Cn minus is Cn minus plus H2O. We get HCN plus OH minus. So the solution is basic because the hydrolysis of Cn minus produce OH minus. So the pH of the basic salt solutions is more than 7. Another example is CH3NH3Cl. It is a salt form when a weak base is reacted with a strong acid. Weak base here is CH3NH2 and strong acid here is HCl. Write a balanced equation to show the reactions between CH3NH2 and HCl. Classify the salt form. What would be the expected pH of the CH3NH3Cl solutions? Explain the answer by using equations. So it's the same step from the beginning. Write down the salt formations. So the salt can be formed from acid and base. So CH3NH2 plus HCl, we get the salt CH3NH3Cl. The second step is the dissociation of salt into ions. So this ion CH3NH3Cl will produce CH3NH3 plus Cl minus. Cl minus is a conjugate base of strong acid HCl. So it is a weak conjugate base. So Cl does not hydrolyze in water. CH3NH3 is a conjugate acid of weak base. So that means this is a strong conjugate acid. So it will hydrolyze in water. So the equation is CH3NH3 plus H2O. We get CH3NH2 plus H3O plus. So since this process produces H3O plus, the solution is acidic. So the pH of acidic solutions is less than 7. Buffer solution. At the end of the lesson, you should be able to define buffer solution and write the Henderson-Hasselbalch equations for a given buffer solution. What is a buffer solution? It is a solution which has the ability to maintain its pH when a small amount of strong acid or strong base is added to the solutions. Example of buffer solutions is seawater, where the pH is between 7.5 to 8.4. And another example is fit for injections. The pH is between 4 to 8. Buffer solutions are important in biochemical and physiological process. Organisms and humans have built-in buffers to protect them against changes in pH. So the human blood pH is 7.4. If the pH is less than 7.0 or more than 7.8, the human can die. Human blood is maintained by combinations of CO3 2-, PO4 3-, and protein buffers. So human blood here is one of the examples of buffer solution. There are two types of buffer solutions: acidic buffer solutions and basic buffer solution. For the acidic buffer solutions, the pH is less than 7. In these acidic buffer solutions, it contains a weak acid and a salt of its conjugate base. For the basic buffer solutions, its pH is more than 7. And for these basic buffer solutions, it contains a weak base and a salt of its conjugate acid. Example of acidic buffer solutions is acetic acid and sodium ethanoate. An example of basic buffer solutions is ammonia and ammonium chloride. So NH4 plus here is the conjugate acid. So here we are going to compare between the unbuffered solutions and buffer solutions in terms of the pH changes. Let's say the initial pH of the solutions is 5.00. When strong acid is added, the pH is 2.00. So we can see that the pH is decreased drastically, and when strong base is added, the pH increased to 12.00. For the buffer solutions, the initial pH is also 5.00. So when strong acid is added, the pH is 4.98. And when strong base is added, the pH is 5.02. So here we can see that it's only small change in its pH. So from these observations, buffer solutions can maintain its pH. Which of the following pairs constitute a buffer? A is a combination of HNO2 and NO2 and ANO2. B is the combinations of sodium hydroxide and NaCl. C is the combination of HNO3 and NH4NO3. D is the combinations of HCl and KCl. Please keep in your mind that a buffer solution contains a weak acid and its salt, or weak base and its salt. So the answer is here is only A. For B is combinations of NaOH and NaCl. So NaOH here is a strong base. So strong base cannot be used as buffer. For C is combinations of HNO3 and NH4NO3. So HNO3 nitric acid is a strong acid, so it cannot be used as buffer. And for D is combinations of HCl and KCl. So HCl here is a strong acid and it cannot be used as buffer solutions.